last time we talked about so in this chapter is about stress transformations and Mohr circle. So last time what we were talking about was about force, and basically we were talking about stress transformations. So if you have an ordinary stress element, if you rotate that stress element, some of the stresses will change. Like the maybe the normal stresses will increase or decrease, and same will happen with the shear stresses. So we come up with these three formulas, which are basically stress transformation formulas, which we can use and we can transform any stress. So if you know the angle, so we can calculate the stresses, right? So we're going to talk about Mohr circle next time. And one of the topic that is remaining other than Mohr circle is about principal stress state or the maximum stresses. So these are the formulas we'll talk about, and in this formulas basically what we will get is the maximum stresses. So for example, we already have transformation equations, right? So transformation equations are helpful when we want to calculate stresses at a particular angle. So you have a normal stress element. If you rotate the stress element and given the angle of rotation, you can calculate what would be the uh, transformed stresses. But what we are interested in is what would be the maximum stresses, what would be the maximum shear stresses. So we are interested in two things. One, what are actually the maximum stresses you can get by rotating the element, and what would be that angle where you will get the maximum stresses. So you have something. So these are transformation equations. Uh, in addition to transformation equations, you will have something called principal stresses. So principal stresses are basically the maximum normal stresses which you will get by rotating the stress element. So you keep on rotating the stress element, there will be a point where you will see maximum normal stresses. So that particular normal stresses are called principal stresses basically. So I will so for example, you have a stress element, and of course in that stress element you have bunch of normal stresses and you have shear stresses. So we want to rotate this stress element at a particular point. So one way is like we can keep on rotating and we can keep on checking the stresses, and we'll see where we'll get the maximum normal stresses. So wherever we'll get the maximum normal stresses is going to be our principal stresses. So for example, let's just say we have rotated the element. At that stress element we are getting maximum. This is the maximum you will get. So you keep on rotating and you have like checked every angle, and the maximum you're getting at some angle, you're getting the maximum stresses. So at that particular angle, this would be a particular angle. We'll call it theta p, and we'll call this principal angle. This is principal angle because at that particular angle we are getting the maximum stresses. And the maximum one we'll call stress 1, and the other one we'll call stress 2. So this stress 1 is actually the maximum stress which we will get by rotating a stress element at a particular angle. And these stresses are called principal stresses basically. So one way is you just keep on rotating the stress element and keep on checking the stresses. Wherever you will get the maximum stresses, uh, those maximum stresses are normal stresses. We're talking about normal stresses. So those maximum normal stresses are called principal stresses, and at an angle that is make this stress element is making is called principal angle. But we already have equations for those principal angle and principal stresses. So I'm gonna give you an angle. So we can calculate this maximum angle by this formula, which is tan of 2 theta p is equal to tau xy divided by stress x minus stress y by 2. So this is the formula, and if you can calculate this theta will give you an angle where you will get the maximum normal stresses. This theta p is called principal angle, which gives maximum normal stresses. So it will give us that particular angle where we can rotate this stress element to that particular angle, and for sure we'll get the maximum normal stresses. And this is important because this is the maximum normal stresses which we will get, and we can compare these principal stresses with the yield properties of the material to see if the failure will happen or not. So that's the most important, final conclusion of all the analysis. And so one way is calculate this angle and use this angle in these transformation equations, and you will get the maximum stresses. But we also have a formula to just directly calculate those maximum stresses. I'm going to write down that formula. So this stress 1, stress 2, which is the principal stresses, you can calculate by this formula as well. So either you can use those transformation equations, or you can just directly use this formula. So this formula will give you the maximum normal stresses. Stress 1 will be the maximum normal stress in one direction. Stress 2 will be on the another direction. And this stress 1, stress 2 is called in plane principal stresses. Similar to principal stresses, because these principal stresses will give you normal maximum stresses. You also have so shear stresses will be at a different angle. So this principal angle will only give you the maximum principal stresses. There is another angle where you will get maximum shear stresses. So in addition to calculating the maximum normal stresses, which are called principal stresses, we also need to calculate maximum shear stresses. And similar to normal principal stresses angle and the maximum stresses formula, we also have formula for shear stresses. So I'm just going to write the formula for the shear stresses. If you guys have written this, so there would be another angle, but let's just say that angle is let's just say this is the angle, right? Where so this is another angle where we'll get maximum shear stresses. So I'm going to call this theta s, and this is, let's just call this, I'm just making this up, but maximum shear angle, shear stress angle. And this will give you maximum shear stresses. And this will also give you a little bit of normal stresses maybe. We'll see about that. Very small normal stresses as well, but overall you will get the maximum shear stress. And the formula for calculating the angle for maximum shear is theta s. It's negative stress x minus stress y by 2 divided by tau xy. And to calculate maximum shear stress, either you can use this angle in a transformation equations, or there's a formula where you can just directly calculate the maximum shear stress. So in exam, I will give you these formulas, but you just have to know how to use these formulas to calculate the maximum shear stresses, maximum no principal stresses, maximum angles where which these normal stress element is gonna make, and these kind of things. So basically, you have to calculate angle where it's gonna get maximum normal stresses, which are principal stresses. This is the formula for the angle. If you want to know at which angle your stress element is gonna give you the maximum shear stresses, this is the formula. And if you can use calculate this angle, and then you can use the transformation equations to calculate the values, or you can just directly use this formula to calculate the maximum principal stresses, which are normal stresses, or this formula to calculate maximum shear stress. So basically, these are the four formulas. And that's all you need on a stress element to calculate maximum values or the values at any particular angle. So if you guys have written this, we can do example 10.2. So example 10.2 is similar. I think the stress element is almost the same as before. But before we were trying to calculate the stresses at a 15 degree. Now what we have to do is that we have to calculate the angle, that particular angle, which will give us the maximum principal stresses. That's the first part. And the second part is we have to calculate those principal stresses. And then we have to draw those principal stresses on a stress element. So we can do this example. So this is the example, right? So we have a stress element. So we already have a stress element. I'm gonna write down the stresses, or let's just write stress element as well. So this is our stress element, and this is stress x, which is stress x is 100 psi, and this is negative, so I'm just gonna write down in a compressive form. So this is stress y is 250, and you have a shear stress which is 100 psi, right? So now what do we have? We have stress x, which is positive because it's in tension. Stress y is going to be negative because it's in compression. Tau xy would be negative because it's making a clockwise rotation, right? So that's our stress element. So what we have to do is that we have to calculate principal angle, which is how much angle stress element would have to rotate such that so basically we have to calculate the principal angle, and that principal angle will give us the angle where we'll get the maximum principal stresses. So principal stresses are the normal stresses. Just gonna principal, we call them principal stresses, but they are basically stresses are basically maximum normal stresses. So we have been talking about normal stresses for quite a while now, but in this case, whatever the maximum normal stresses you're gonna get because of rotating the stress element are called principal stresses. So we just have to you calculate this. So we know the formula tan 2 theta p is equal to tau xy over stress x minus stress y by 2, right? So we need this theta p. So it's gonna be theta p is going to be equal to uh, tan will go there and it's gonna be tan inverse tau xy over stress x minus stress y by 2, and then this is gonna go there. So that's so tan will go there, it's gonna be tan inverse, and then you'll have 2, you're gonna divide it by 2. And if you use the values, theta p would be 1 by 2 tan inverse. Our tau is negative 100 divided by our stress is 100 minus 250 divided by 2. So if you calculate this, you can use your calculator to make sure you're also getting the same value. So you're gonna get negative 14.87 degrees centigrade. Uh, Sorry, degrees. So that's the angle where you will get the maximum normal stresses. Any other angle you can use in transformation equation, you're going to get lower values than what values you're going to get at this particular angle. So one way is use this angle in the transformation equations, and you can calculate stress x, stress y, tau xy, which will give you the maximum normal stresses, but uh, no shear stress maybe. So you only get the maximum normal stress. So now that's the angle which we were trying to discover, and now since we have to determine the principal axis stresses as well. So now we're going to use the formula, this new formula which we got. Stress 1 and stress 2 is equal to stress x plus stress y by 2, positive, negative, stress x minus stress y by 2 whole square plus tau xy whole square. So basically these are like, once you have to use positive, once you have to use negative. So I can just break this down. So stress 1 is equal to stress x plus stress y by 2. One time I will use positive, right? Positive tau x minus stress y by 2 whole square plus tau x y whole square. So maybe you can try to do it yourself. If you cannot, then I will do this. But if you use this formula, you're gonna get 126.5 psi. You guys all can try if you're getting the same value. And stress 2 would be equal to stress x plus stress y by 2 negative stress x minus stress y by 2 whole square plus tau x y whole square. If you use this, you're gonna get negative 276 psi. before the stress, I'm just gonna copy the. So this is our stress element before. Oops. Oops. Okay, I might have to draw. So this was our stress element before. We had stress X, which was 100 psi. We had stress Y, which was compressive, and it was 250 psi. And then we have a tau xy, which was 100 psi, right? So these were the stresses. So stress X was 100 psi, stress Y was 250 psi, tau xy was 100 psi. We want to rotate the stress element to a point where we'll get the maximum normal stresses. One of the stresses, I mean maximum normal. So right now the maximum normal stress we are getting is 250 psi. We want to get what would be the maximum stress we are ever gonna get by rotating the stress element, and that maximum stress is gonna be compared with the overall material property, like either the member can have enough strength to take that much amount of stress or not. So that angle which we got was 14 degrees. So I'm gonna rotate the stress element. So this is 0 degree, and this is going to be uh, downward is going to be negative degree, so it's gonna be tilted downward a bit. So this is going to be our stress. One was 126 psi, and this is in tension. So this is our stress 1, which is 126.5 psi, and our stress 2 is compressive. So this is stress 2, which is 276 psi. So this is the final result. So the maximum stress you're ever gonna get is 276. So you can use any other angle, you're not gonna get more than 276 psi. So that's the maximum stress this stress element is gonna experience, and that you have to compare it with the maximum capacity of a material. If the material can take more than 276 psi of stress, then the material is safe. If it cannot take that much amount of stress, if the maximum capacity of material is maybe 250, then the material will fail. So what I want you guys to do is use the, so we already know the theta, right? Oops, theta is, so our theta is minus 14.87 degrees, right? So that's the angle, principal angle, and you can use transformation equations to calculate stress x, stress y, and tau xy. And we'll see what results we are gonna get. So you can use like the transformation equations which we have used before, but instead of, so you can use this angle, minus 14.87 degrees. And since this angle is 14.87 degrees, we know this is 90 degree, right? this whole angle. This is 90 degrees. This is also 90 degrees. So we can calculate the remaining angle by just subtracting, which is going to be 90 minus 14, which is going to be 75.12 degrees. Because this force and this force, they are like perpendicular, right? They're making 90 degrees. So either it's minus 14.87 or 75 degrees, the same thing. So now you guys can use the transformation equations and calculate stress x, stress y, tau xy, given this principal angle. And we'll see what values we are getting. So use transformation equations. Stress X we know is 100 psi. Stress Y we know is negative 250 psi, and tau xy we know is negative 100 psi, and theta p we know is negative 14.87 degrees.